All right, in this video, let's talk about the binomial distribution. We've already seen an introductory example of this with the marble example with the red and yellow marbles. But what I want to do is talk about this in general. So the binomial distribution is going to be the distribution that we're going to get when we can do one of two things. The idea is you're going to do some sort of operation and there's only going to be two outcomes. Either, so like we had a bag of red and yellow marbles. You get a red marble or a yellow marble. There's no third marble. If you have more than two options, this is called the multinomial distribution. It's more complicated. We're not going to get into it at all. So we're just going to deal with when we have two options. And you can think of these two options as being a success versus a failure, if you want to think about it that way. So in our previous example, success was picking a yellow marble, failure was picking a red marble. I want to be careful that using the word success and failure does not intrinsically mean that one is better than the other. It's just that people use the word success and failure to mean this certain event happens versus the other certain event happens, right? So when we say success and failure, we're not talking about the actual, how desirable the outcome is. It's just we have two outcomes. So either A or B happens, nothing else. So with the binomial distribution, here's what we're going to do. Let's say that the probability of a success, so the probability of success is P, and then the probability of a failure, since there's only two options, the probability of a failure is 1 minus P, because we know that they have to add up to 1. So that's how we're going to do that. So the probability of a success is P, probability of a failure is 1 minus P. And let's say we do N trials. So in other words, we're going to do some experiment N times. So in our previous example, our experiment was we picked 4 marbles out of the bag with replacement. So in other words, we picked a marble out of the bag, looked at what it was, put it back, and then did it 4 times. That 4 was our N. So N is going to denote the number of trials. So N is the number of trials. And then our random variable is going to count the number of successes. And then what we want to do is come up with a formula for how do we figure out the probability of, say, X successes out of N trials, little x. So let's say we want to count what's the probability of there being exactly little x successes. And so the way that this is going to work is, and we've already seen this story before, but we need to think about how many ways are there exactly to get x successes. And so if we have n spots, so we have n spots here, and we want to choose x successes, how many ways are there to do that? Well, n choose x. Okay, here, by the way, x is got to be between 0 and n. There's no way that you can have n plus 1 successes if you only have n trials. So just as an aside, but that's good because that means that n choose x is always defined. And then that's the number of ways to get exactly x successes. And now we need to think about what's the probability of one of those ways. So what's the probability of getting exactly x successes? Well, it'll be p to the x times 1 minus p to the n minus x. Because we know that the number of, we know that these two exponents have to add up to the total number of trials. In our previous example, those exponents added up to 4. And so this is really all we need to know about the binomial distribution, okay, is this formula. So if we have this formula, then we should be pretty good. Just keep in mind, I just want to make a small note here. This n choose x is my preferred notation, but the book has a different preferred notation. The book likes to write this as C of n x. So that would mean that their formula would be the probability of little x successes is n choose x times p to the x 1 minus p to the n minus x.